Okay, so our first example is similar to ones that we've seen before about a boat being pulled onto the shore using two ropes. So we have two people pulling the boat. The boat is over here, and here's rope 1, and here's rope 2. Very similar to the questions we've seen before. But this time, instead of knowing what our tension is or our force in those two ropes, what we know is what we want the resultant to be. We want the boat to travel on this straight path, this straight red path, with a force of 3,100 newtons. So the question this time says how much force is needed in each rope. So comparing this to what we just did in the last slide, what we're actually doing is resolving into the vector components of this diagram. So what vector do I need along rope 1 and what vector do I need along rope 2 so that it will result in 3,100 newtons. If you need more time to copy the question down and your diagram, just ask the supply teacher to pause. So let's try and imagine what these vectors would look like. So I'm going to grab my blue vector here, and I know that there is going to be some vector in this direction, you know, sort of like the KU vector that I drew before. So I'm just going to guess that it's about that long, and I'll call that F1. Then we're going to add a second vector along rope 2, you know, maybe that long, and call it F2. Now, I don't know exactly how long they are. It's just guesses. But let's just clone this guy and see if I added it onto this vector, you'll see, okay, well, something's not long enough. Either F1 or F2 aren't long enough. Probably a bit of both. I'll move this over and realize that this vector has to be a little bit longer, so this vector must have been a little bit longer, and F1 has to be a little bit longer. But remember, we're just sort of guessing anyways to draw our picture. But you'll see that this question is asking us what two forces do we need to result in the 3,100 newtons. This is actually very similar to the chandelier or the sign question where we had to find the tension in the two ropes. It's virtually exactly the same question, except we're now calling it resolving into vector components. So how much along rope 1, which we're calling F1, and how much along rope 2 is necessary to resolve into 3,100 newtons. Next, you could take this scenario and actually draw a vector diagram off to the side. But if you notice the triangle that we have in the top here is exactly the vector diagram we draw. So I think we can actually use this picture as our vector diagram as well. The difference is in this triangle on the top, I only know one of those sides, or one of those angles. So I'm going to have to figure it out. I got the 20 here, that's easy. But you notice the 30 is right here. Well, I can use my Z pattern and go this and this to get that this is 30. And then, of course, 20 and 30 equals 50, subtracted from 180, makes this angle 130 degrees. In the questions we did before, we were using a lot of cosine law first, but the cosine law requires two sides and a contained angle. Here I only have one side, the 3100. So I'll probably have to go to the sine law to solve for F1 and F2. So let's try that. Since F1 is what I need, I'm going to put it on the top over sine something. Well, it's the opposite angle. So there's F1. So the opposite angle is 30, so sine 30. And then I need to compare this to two angles, an angle and a side that I know, a partnership. And you see there's the two partners I know, the 130 and the 3,100. Since I started my ratio with F1 on the top, I've got to use the 3,100 on the top over sine 130. If I've set this up the way I like, you notice all I need to do then is multiply the sine 30 up there. F1 equals 3,100 sine 30 over sine 130. Punch that into your calculator, and I get 2023.4 newtons. So you can check that number and make sure that you got the same thing. F2 is going to be found exactly the same way, so I'll just do it very quickly. F2 over its opposite side, which in this case is 20, so sine 20, and I'll compare it to the same ratio of 3100 over sine 130. Solve, and you'll see that F2 is equal to 1,384.1 newtons. So again, double check that and make sure that it matches up with what you got on the calculator. So like I said, this question is virtually identical to the sine question or the chandelier question, just with a little bit different terminology in that I've resolved this into vector components. So how much force did I need along the rope 1? What component of rope 1 did I need? And what component of rope 2 did I need in order to produce 3,100 newtons along the red vector?